So thanks for the introduction, Ian. So my name is Aoife, and it's a very Irish name. So five letters, four different vowels, bit of a tongue twister. So I do apologise. So as Jan said, I'm in the University of Limerick, which is in the Republic of Ireland. And today I'm just going to show some work I've done along with my supervisor, Dr. James Sweeney, and our collaborator, Dr. Ruth Carden in University College Dublin, on joint species spatial modelling for deer count data. Um, so I'm sure a lot of people on this call aren't too interested in deer, so I'll just show a bit of motivation as to why we're interested in this. Oh, no, I won't. There we go. Okay. So the Irish Times is one of our national newspapers in Ireland. And back in May, they ran an article that essentially was on about the record number of deers hunted in the Republic of Ireland, with over 55,000 deer hunted and recorded to be, shot and culled and all those things. But if we look over, if we say to the clip on the right, I'm just going to highlight something here, which is that the overall size of the population is unknown, right? So this is a bit of an issue because we have three main species of deer. Two are invasive or non-native, and for various reasons, we'd like to know what the population size is. So we have three main species of deer. So in the pictures from top to bottom, it will be fallow deer, red deer, and then sika deer. So red deer, that deer in the middle of the three plots, is our native deer. And then fallow and sika have been introduced, so they're non-native or invasive. A lot of work has been done, let's say, from an ecological perspective on like how the deer get on with each other, like how friendly they are with each other. So red and sika would be quite friendly with one another, so they don't mind sharing their habitats with one another. But fallow and sika do their best to avoid each other at all costs. So we want to see, well, can we leverage this, let's say, overlap or non-overlap in range when we're building our models? So why we want to estimate the population sizes is for various reasons. Firstly, would be, let's say, mainly conservation and management of the herds. So back in the early 20th century, I believe, red deer almost became extinct. So we don't want that to happen again, seeing as they are a native deer. Deer can tell us an awful lot about forest health. So if we know how many deer there are in the forest, that's a good idea. And lastly, for disease transfer, we say, between livestock and wildlife. So in Ireland, we have a disease called bovine tuberculosis, which is, I think, nearly eradicated throughout most of continental Europe, as we say. And deer are thought to be a transmitter of this disease. So, but again, if we don't know how many deer we have, well, we can't actually say for certain whether they transfer the disease to cattle or not. So if we go to the data, so we have four different data sets, shall we say. We start from left to right on the table. So first of all, we have what we call our observational count data. So this is when people have gone out to, say, a 10-kilometer square, and they say how many deer they have seen within that square. These people are very good, and they know what the different deer look like from far away, so they can tell us what species they're. It's not presence only data. They do record if they've seen no deer. So we have presence absence data there. We also have the number of deer like culled or hunted by licensed hunters. And we know, again, the breakdown of this species by each county. So we have 26 counties in the Republic of Ireland. So we know in each of these counties, well, how many of each species were hunted. We also have the number of hunting licenses granted. So for these hunters, pardon me, how many of them actually were granted. And then finally, we incorporate the current land cover data from the EU. So it's, for people who don't know, it's like a pan-European wide, and they tell you, well, what different, let's say, landscapes or land coverings are across different areas. So we selected 14 of these and take the associated percentages with each across the 10-kilometer squares. So hopefully, excuse me, you can see we have two different spatial levels, right? So we have a 10-kilometer square, and we also have the county levels. So I'm sure some of you will be like, what do counties look like? Which is a very good question. So I'll just show you what our data looks like. So we take hunting season from 2017 and 18. So the hunting season in Ireland doesn't follow a calendar year, kind of merges between the two. So it starts in September and kind of runs until about March. And across here, we just have the three different species in the 26 counties of the Republic of Ireland, and just the different, we say, what we call the bag numbers. So the returns that the hunters have given to each of the counties. So the scales on each are quite different. So red, again, because it's almost extinct, the numbers are quite low. They're in the hundreds, maybe up to thousands in the north of the country. But if we looked to the rightmost plot, so for Sika deer, the bag numbers are almost in the 15,000s in one county. So it's very hard to compare these two. So what we do is we say divide by the number of licenses granted in each county, and we could maybe take this to be a proxy for hunting effort. So I'm going to say the pattern across the counties doesn't change too much, but it's now nearly easier to see the hunting effort that goes on for each species in each county. And then lastly, we have that 10 kilometers squared level data, which is our observations. So there's no restriction on how often someone can go to a square. So we have some squares that are visited almost 15 times. So there's no point showing the magnitude. It's very hard to show 15 visits. So we'll just show how many visits are in each square. But again, patterns kind of similar to the last plots, and they have gone to where they think the deer will be. So we do have preferentially sampled data. In our models, at the moment, we don't do anything about this. We just kind of go, oh, it's there, nice hand waves, but we don't actually do anything. So that would be something we could look at a bit better in the future. So then, our joint species model, well, how do we do it and what's it all about? So we use the N-mixture modeling framework that Royal introduced back in 2004. And when we fit it using the Nimble package in R. We did try using JAGS and STAN and INLA, and for various different reasons, those packages didn't work. I do apologize. The model is going to look a bit messy because we have 4 different subscripts. But at each time, I will once again go through what each of them mean. So don't panic too much if you're kind of going, what? This is a bit confusing. That's perfectly fine. So if we start with that 10 kilometers squared grid level, we've an N-mixture framework model on this. So to start with, we have the population of one of the species at a grid square, and we say it comes from a negative binomial. We originally tried a Poisson, but that couldn't really handle the overdispersion, so thus we went with a negative binomial. And we parameterize this such that the mean is lambda. So that gives the 2 showing there for P and R. Next, we have our observations, so the people who went out and visited each site. Again, this is going to be dependent on N. So this I element of G just means the observation I happened at grid square G. And then we also have our detection probability D. Then we model the mean of our populations. And we're saying that that's coming from we do it on the log scale because it has to be positive. And we're saying that comes from the 14 land cover variables with some coefficients. We put a Bayesian lasso prior on the betas because X is compositional in nature, so that the rows sum to 1. This leads to an awful lot of problems. So we use the Bayesian lasso for our beta prior. And then we have our spatial surface phi. So phi cone is given a multivariate ICAR prior, and various reasons, but we won't go too much into that. That's what we use. And then finally, we model our detection probabilities. So we say that this is dependent on what we call our grouped land types. So from the 14 categories of our land coverings that we selected, we group them into 4 to make life a little easier. And they're grouped based on what deer like and do not like. So, for example, in that bad grouping, we say burnt areas, urban areas, marsh, sea, ocean, and beach. So deer don't like these areas. I don't know if humans like them either, but on a whole, deer don't like these. So we say, right, they're for bad. Deer won't generally be there. Peat, Ireland have an awful lot of peat bogs, and coniferous forests grow quite well in peat bogs. So we included these in their own category. One of the reasons for this was the native red deer have been pushed, I would say, upland into these peat bogs, and we wanted to see actually if this could come true in our models. So that's the grid square level of our model. And then we have to look at the county level. So this is like the next level up in our spatials. So it's quite nice. It's only 2 lines, so it's not too hard, I promise. Firstly, we have what we call our county population. And all this is it's the sum of all those squares that are within a county. And then we have the culls. So these are like the reported numbers that the hunters give back. And this is just some cull percentage times the population. We've the Poisson approximation here for the negative binomial, purely because from mixing problems when we used the negative binomial. Why they occurred, I'm not sure. We didn't investigate that, but this is what's worked best. So with these cull percentages, because we don't know the population, well, these are also unknown. So we have to estimate these. So with our collaborator, Dr. Ruth Carden up in UCD, these were informed when we looked back at trends in these, let's say the hunting effort over time, and we've classified them alongside Ruth into 3 groups. So we have kind of like a low, a mid, and a high. I won't get into how we classify them, just that there's 3 groups, and each group then has its own mean and standard deviation. So firstly, I went off and I fitted it all and found we had identifiability issues between the cull percentages and the detection probabilities. So the model can't estimate both of them at the same time. We need to fix one and we can estimate the other. And because the county level data is more, there's just more of it and it's a bit more, ground truth. We fix the cull percentage and we learn the detection probabilities, and then we can change the cull percentages and get new detection probabilities. In this presentation, I only have the results when we used the mean cull percentage for each group. I was waiting on the models to run. They're quite computationally expensive, so we only have the mean results to show here. But what we have done is we have sampled what we call 100 sets of cull percentages. So for each county and each species, we take a sample. So we'll end up with 78 cull percentages in each, sample set. And then we run them and then get the results. So if we just look at these mean results, well, first of all, what are we most interested in is our population estimates. So as we can see here, fallow and sea hare have quite large populations. And as I said before, seeing as the red deer almost became extinct, their population is much lower. And below each of the medians there, we have the associated 95% credible interval. The median estimates are what experts believe to be in and around what the numbers they thought of. So that's always a nice validation that it is what the experts think it is. When we look then at the coefficients, the betas, again, we put a Bayesian lasso prior on these, so we're not surprised that the majority of them are, shrunk towards 0. There are a few that do not have 0 in the credible intervals. That would be pastures for fallow deer. So that again is in line with what ecology would know, in that fallow deer like pastures. And again, what we see for the peat bogs, so this one here, we have red deer and a high association here. And again, that's due to the red deer being pushed out of what would have traditionally been their natural habitats. Then we have the spatial surfaces. So hopefully these colours come out very well on most people's screens. But again, most of all we see here is that just a pattern. So we can see that fallow deer kind of like the Midlands, which is, as the experts believe. We have red deer, they're a bit more scattered, but again, that is kind of as the experts would say. And then Sika deer have this real hot spot here in the southeast of the country, which we had seen in those bagged numbers previously. The bottom row of the map, shall we say, just shows the standard deviations associated with the spatial surface. And the yellow triangles are, squares for which have been visited at some point at least once. And these then have lower associated standard deviations, which is always nice. And then finally, we have the coefficients, we'll say, for those the detection probabilities. So, for example, if we see here, we've good and the associated values there for red deer are quite low. So what we could kind of interpret this to being is like, oh, if you have a high percentage of good land in a square, you are less likely to see a red deer. And this is because red deer are no longer there. But if we look at coniferous and peat up here, this is red deer again, but the higher the percentage of coniferous or peatland in a square, the more likely you are to see a red deer if it is there. So just to wrap up then, we've estimated the populations of the three main wild deer species in the Republic of Ireland with uncertainty for the first time. Previous work has been done on abundance and presence only, as well as like the distribution of deer, but never on estimating the numbers. And we've just finished running where we sampled the cull rates, and that added additional uncertainty to our estimates. We modeled the three species jointly, just so we can borrow information across the species. This does make inference quite challenging, and it is substantially more computationally intensive than if we just modeled each of the species individually. But we thought it was more beneficial to do it this way because of the paucity of our data. But we are quite reliant on expert opinions, especially in forming those cull percentage bands. And what we hope to do then is when we have all this done and it's lovely and it looks great, we're hoping to use the results then to inform future surveys for rerunning these models with a temporal aspect to it. These are a few references in case people would like to read a bit more about Irish deer. And then just like to thank our funders for this. We were Science Foundation Ireland Centre for Research Training at Foundations Data Science, my supervisor, Dr. James Sweeney, and our collaborator in UCD, Dr. Ruth Carden. Thank you.
Thank you for your very interesting presentation. We have plenty of time for questions, and maybe I would like to start with one. You have the data from 1 year only?
Yeah, unfortunately so. Yeah.
But would there be possibility, for example, to get the data even next year?
Yeah, so the hunting season has actually just started. So it started on the 1st of September. So Ruth has gone off and has started collecting data and got all her comrades, shall we say, to gather the same data they have previously. So that data then should become available, I'm going to say about May time, hopefully. So then we could add that temporal aspect to it and see how that would do. Yeah.
And have you already thought about how you incorporate how this population changes from year to year?
Yeah, we've spoken about it in a few meetings. It'll be a challenge to say the least.
I can imagine.
Yeah, but it'll be fun. I don't think my laptop will enjoy it, but I will.
Okay. Any other questions from the audience? Zikita, please.
Yes, thank you very much. First of all, do you have any reference studies for the rest of Europe or any sort of estimates which are historical? And the second question is, can you possibly show where the human population is concentrated in the Republic of Ireland? Because I'm sorry for being uninformed, but when I look into your plots, there is always an area where there is basically no deer, and I simply don't know where the humans reside.
Yeah,
so sorry for the other question. Yeah, thank you.
No problem. So to do with the first question, so as far as I know, I haven't seen many studies done on estimating deer population across Europe. I could have missed them. I'm not a deer expert in any means at all. They have done quite a bit in the States, particularly in Chicago, I believe. They have a problem, or I call it a problem. They say it's a problem, with a species called white-tailed deer, and diseases associated with them. So I haven't seen too much across Europe. Again, they do an awful lot of, let's say, abundance mapping, but not so much estimating populations. I will reshare the screen, so bear with me, and we'll bring up the maps. We go to the squares, that might be a bit easier. So, oh no, okay, we don't need to save James's face again. So here in Ireland, so most of the population will be in Dublin, which is our capital city. So Dublin is kind of in and around here. So here and here again. We'd have other centres of populations down in Cork. So I say about here-ish. Testing my geography skills as well. So deer typically don't like mountains, except for Sika deer. So Wicklow would be quite mountainous. Here's my mouse. So it's not surprising that we see Sika deer in Wicklow because of the mountains. There are other things at play as to why some species aren't in other counties. Typically, deer don't like humans. So for that reason, we excluded, we say, the national parks because they're in the city centres, and it would just skew our data. I'm guessing you're actually on about this funny looking bit here. So Ireland had a Taoiseach, or a prime minister, who populated an island off the coast of Kerry with deer. There's nothing else on this island apart from deer. And for the spatial model prior, the CAR model, all squares need to have a neighbour of some sort. So this peninsula here is all actually water, bar this, which has a small piece of land that is actually populated by deer, because they were brought out there. So maybe that's what you were referencing.
Yes, thank you very much.
No problem.
Yeah, we still have a minute for one question. Andre, I have seen that you were the first, but would you be kind enough to give a space to Anna?
Of course, please, Anna.
Thank you very much. And thank you for your very interesting presentation. My question is just very simple. As you mentioned, I believe that it's more interesting to do a joint modeling approach, but have you tried, or are there any other studies for doing this kind of evaluation of the population that do not consider the joint modeling of the populations, and how does your model perform in comparison to those? If you could comment on that, I appreciate it.
Yeah, no problem. So previously in Ireland, what someone has done is they have taken a cull percentage that they have picked. So I think they picked 30%, and divided all those hunting returns numbers by 30 and went, that's the population, and had lovely like hand waves and everything. If you do that, yes, that our models kind of align to that, and that we pick something similar. But we do it jointly so that we can actually maybe borrow information from, we'll say, the deer that we see more often. So fallow deer, we see them quite a bit, and we know they don't like Sika, so we can learn a bit more about Sika in those regards. So yes, they somewhat align, just to divide them by a picked cull percentage that people have done previously. Yeah.
Thank you.